Equation of normal to parabola. Standard form we will take. Let y square is equal to 4ax is any parabola is there, and at any point P. First we will find in parametric form. This is the tangent, and normal is any line perpendicular to tangent passing through the point. So this will be normal. This angle has to be 90 degree. So this point P is taken as 80 square comma 280, a general parametric coordinate. So we'll find equation of normal. dy dx we have already calculated 2a upon t. Again we will calculate 2y y dash is equal to 4a. So y dash is equal to 2a upon y. Y coordinate at that point is 2at. So this is equal to 1 upon t. So slope of normal m. Slope of normal. This is the slope of tangent. So slope of normal will be minus t. This is m, slope of normal. So equation of normal will be line passing through that point. Y minus 2at is equal to minus t into x minus at square, or y minus 2at is equal to minus tx plus at cube. So you can write y is equal to minus 2x plus 2at plus at cube. This is the equation of normal at point P. And point of normal C, or feet of normal, is 80 square comma 280. This is the feet of normal. So feet of normal is 80 square comma 280, and equation of normal is this. We can write equation of this normal in slope form also. We know the relationship between slope of normal and parameter t is m is equal to minus t. That means here if I replace t with minus m, so I will get equation of normal in slope form. Slope form. So from that relation I know m is equal to minus t. So replace t is equal to minus m. I will get equation of normal in slope form. So y is equal to mx. This t will be replaced by minus m. T is equal to minus m. So minus 2am. And this will be a minus m whole cube. Minus m whole cube means minus 2am. Minus am cube. So y is equal to mx minus 2am minus am cube. What we have done? I am replacing here t with minus m. So if slope of the normal is known, I can calculate equation of the normal in this form. Y is equal to mx minus 2am minus am cube. In slope form, feet of normal C, that P point was 80 square comma 280. So this is same as, replace t with minus m, am square comma minus 2am. This is the equation of normal, which we can remember both formulas. Y is equal to minus tx plus 280 plus 80 cube, or y is equal to mx minus 2am minus am cube. Equation of normal. Now question arises, from a point how many normals can be drawn? From a point. Number of normals that can be drawn. So suppose there is a point R, H, comma, K. This normal is passing through this point. So we will write, replace K, this normal is passing through the point R. So K, number of normals. K is equal to mh minus 2am minus am cube. That means I can write it quadratic, am cube plus 0 into m square, there is no term containing m, plus m into 2a minus h plus k is equal to 0, transferring all the terms to this side. So plus minus plus minus. using the concept sum of the roots. This equation is cubic equation, so maximum I can have 3 normals, and definitely we know that cubic equation, odd order equation, will have at least one real root. So this equation will have at least one real root. That means wherever is the point, inside, outside, at least one normal will be always there. But maximum I can have here 3 real roots. So the possibility is from this point I can have 3 normals from here. 3 normals are possible, and their slopes are m1, m2, m3, which will be roots of this equation. So from this equation we know that m1 plus m2 plus m3 is equal to 0. m1, m2 taken 2 at a time, m2, m3 plus m3, m1 plus minus plus. So 2a minus h upon a, and product of roots m1, m2, m3 is equal to minus k upon a. m1, m2, m3 is equal to minus k upon a. So these 3 equations we will know, where m1, m2, m3 are slopes of the 3 normals which are passing through a single point. This P is known as conormal point, and these are the feet of normals. So from a point, this R, I can draw 3 normals. If I know this m1, this P point, I can calculate am square minus 2a m1. This will be, feet of this point will be q as, this will be am2 square minus 2a m2, am3 square minus 2a m3. So sum of the 3 slopes of the 3 normals will be always 0. This gives that from a point, if I can draw 3 normals, sum of their slopes, sum of the slopes of the 3 normals drawn from a point will be always 0. So point, if I denote these points by R is this, suppose this is Q, this is S. So I can receive easily P. Point is a m1 square comma minus 2a m1. Point Q, m1 will be replaced by m2. A m2 square comma minus 2a m2. This is not rocket science. So easily you can write S also. So what will be S? Replace m1 with m3. So a m3 square comma minus 2a m3. So one thing you can observe here, some of their ordinates of conormal points, this PQ, S are conormal points. This P conormal points. P, Q, S. That means feet of normals drawn from a point are known as conormal points. So their ordinate y1 plus y2 plus y3, ordinates of conormal points. Sum of ordinates, summation of yi, I is equal to 1, 2, 3. That means y1 minus 2a, you can take common, m1 plus m2 plus m3. This will be always equal to 0. So sum of y coordinate will be always equal to 0. That means sum of ordinate of conormal points will be always 0. So y is always 0 here. y1 plus y2 plus y3 is equal to 0. That means here one very tricky question which is very useful for objectives particularly. If I form a triangle PQS, now I am talking about triangle PQS. What will be locus of centroid of triangle PQS? Locus of centroid of triangle PQS, or where will this centroid of triangle PQS will lie? So you can see PQS y coordinate, y1 plus y2 plus y3 upon 3. So this y coordinate always 0. That means that will always lies on axis of the parabola. So centroid of triangle formed by three conormal points will always lie on parabola. Again, I am repeating that. Centroid of the triangle formed by three conormal points P, Q, S will always lie on axis of parabola. Why it will lie? Because y1 plus y2 plus y3 will be 0. Y coordinate will be 0. When y is 0, it will lie on x-axis. And in this case, x-axis is nothing but the axis of the parabola.